All right. We are graphing by transformation, and um, I would say potentially, or I'm fairly certain, other than plotting points, this is probably the most important graphing lesson. Um, Transformation does make graphing a lot easier, and it really gets out of the idea of plotting points. Plotting points is fine. You can do it for any graph, but it is tedious. It's a very tedious process. So number seven, let's make this a little bit thicker. Number seven, they give you two graphs. They give you a g of x graph, actually f of x graph that looks like this. This is our parabola y is equal to x squared. And then they give you a new graph, where it's like shifted over 2 units and up 1 unit, and it's reflected. It's like that. This is the parabola, and I know this is y equals x squared. And so to shift it over to the right, you're going to have to do an x minus 2 with the x value or the input value, and then you're going to go up 1 unit so it look like this. At the same time, you're flipping it across the x-axis or flipping it down, so you're going to pick up a negative. But they don't tell you like f of x is equal to this. They say, we don't know what f of x is, but to get g of x, what do you have to do with it? So g of x is going to be the f of x flipped, f of x flipped, moved over 2 to the right and up 1 unit to get the g of x function, which turns out to be b, I hope. That's number 7. Number 9, this is y is equal to the absolute value of x minus 3. I'm hoping you understand that the absolute value, its parent function, is something that looks like this. I'm hoping you understand that. Uh-oh. No, my pen died. Give me a second. All right, I'm back. Anyways, the parent function, the absolute value function, is going to look like this. You could get that equation by piecewise, but I feel like we've done it enough to look at that. Anyways, there's that guy. Now what's going to happen here? Well, this is minus 3 is going to happen to the y value, so the whole thing is going to shift 3 units down. So our transformation, this thing simply shifts 3 units down. Describe the transformation and relates to the parent graph. Okay. Number 11, not very interesting. Number 11 is y is equal to x plus 2. I mean, technically, I think you could say it either way, but this thing's going to shift up 2 units. It's going to shift up 2 units. So our original parent function looks like that, y equals x. So this is going to be shifting up 2 units. So then we have this type of stuff. If you wanted to, you could have done it as x plus 2, like it's in with the domain, which is going to shift 2 units to the left, which is going to be the equivalent function. It doesn't matter for a linear function, whether it's like plus 2 with the y value or plus 2 with the x value. You'll get the same answer. It's not a very good transformation graph, but it is what it is. This is the absolute value of x plus 6. Again, its parent function, y is equal to absolute value of x, is simply this guy. Oops, that's for 0, 0. And this is going to shift 6 units to the left. So then it's like 1, 2, 3, 4, 5, 6, 6 units to the left. And there is the absolute value function. Again, we don't have to do that piecewise nonsense. We don't have to plot points. It's like, there it is. There it is. It makes it really easy. On to 15, describe the reflection. I guess easy. All right, so then I got y is equal to negative x squared. Our original function is x squared. Its parent function looks like y equals x squared. Y equals negative x squared. I don't rerun it. It's going to reflect it in the x direction. So we're going to get this as the answer. That's no big deal. Like the negative is in front of the function. All right, on the next one, the negative is with the input. So it's like with the x value. Our original function, wow, this is not going to be very good. The absolute value of x, our original function looks like this. The absolute when that negative is in front of that, it's not in front of the function, it's in the input or the domain. This is going to reflect across the y values, like it's going to reflect, and it's going to be the exact same function, which is not very interesting. I don't know. I kind of want to like convince you of this by using a piecewise function, but I might be a little bit over it. And I'm going to continue. It's the exact same function, by the way. On to 19. Yeah, 19, I think. 19, I got y is equal to negative x. It's in with the input. And again, the line, it doesn't matter. So y, or my parent function y equals x would look like that. Y equals negative x would be reflected across the y-axis, which would be the same reflection if you did across the x. But it would look something like this. Imagine reflecting across this line. That's no big deal. It's not very interesting. The next one, it says describe the dilation in each function. Okay, so we got 21, y equals 6x. So our parent function is y equal x. Y equals 6x. We get like, it's being stretched vertically. We're stretching it vertically by 6. Technically, if you regroup this, what you can, you're compressing it by 6. Compressing it horizontally by 6. All right, so I got y is equal to, let's see, 23. That was going to be fast. Y is equal to, is that greatest integer or absolute value? I think it's absolute value. 2x. It's not very interesting. So then we get our parent function is the absolute value of x. It's in with the x. This is in with the input. So therefore, we're going to compress horizontally. When we compress horizontally, our original function y equals x looks like this. Our compressed horizontal function is going to look like this. And it is true, compressing horizontally is equivalent to stretching vertically. Compressing horizontally, compressing this way is the same thing as stretching vertically. I hope that makes sense. All right, on to the next. 25. I get y equals 1/2 x squared. Y equals x squared is simply a parabola. So this is going to compress it vertically. It's like less than 1. So therefore, our new graph is going to be like flatter. I don't know. Flatter. There we go. Or stretching horizontally. Compressing vertical, stretching horizontally. All right, 27. 27 describes the transformation in the graph of the function in green as it relates to its parent function in blue. All right, looks pretty easy. I got my parent function in blue and my new function in green. And obviously this is shifted up. It says 7 units. Yeah, 7 units makes sense. Yeah. I don't know if I need to do the functions. This is y equals 0, and this is y equals 7. It's not very interesting. 29. Okay, I like 29 better. I don't know if I'm going to draw it. But you got a couple things. It shifted to the right 5 units and reflected about the x-axis. I'm not sure if they want us to write the function, but our original function is the absolute value of x. Our new graph is shifted to the right 5 units, so x minus 5. And at the same time, it's reflected upon the x, so you pick up a negative. 30. 31, actually. I'm tracking along. This is a fast unit. 31. It's just shifted up 8 units. I wonder if I can come up with the... It's like the original function... Is that a 2? I think the original function has the equation y is equal to x plus 2. And then we're shifting this up 8 units. So you get y is equal to x plus 2 plus 8. Yeah. 31. Use a transformation of the paragraph to write an equation for the function represented. Okay. So this is kind of what I was doing, I think. 33. You know, they give you a parabola that's been shifted up 1 unit. So if the parent function is y equals x squared, its transformation is x squared plus 1. And no big deal. 35. I get, I'm not sure if I fill this one. It's not, let's see, I think this is -5. Yeah, this is -5. And if I had to guess, its parent function would be y equals x. And so it's like y equals x minus 5. It's been shifted down 5 units. 37. Again, this is a parabola. It's been shifted 2 to the right. So it looks like we know our parent function is y equals x squared. So a parent function shifted, or parabola shifted to the right is simply y equals x minus 2 squared. And I think I'm done. That's quick homework.